everybody, welcome to another live video here at Rogue Fabrication. Josh, this guy right here, is going to be doing all kinds of behind the scenes stuff. He's the one that you usually talk to on the phones, and he is going to be the one who helps show some stuff on screen. You guys have seen most of our recent live videos. If you're here, I'm guessing those have all been for the purposes of announcing winners. We will have 3 winners during this video. We're going to likely make you guys slightly compete for that, but the cool thing is these are smaller prizes and they're limited to just people watching this live Q&A video. So this is a question and answer session. I'm Joe. I founded Rogue Fabrication. I'm here to answer any questions you guys have about our products, our services, shipping lead times, using the products. I give you guys chances to submit questions through comments on our video in a chat thing. One of you did that. I've got an answer prepared for that question, and then anything else, I will try to address them here in the live video. The fun thing about this, you guys get to comment, we get to interact. Challenge is, I haven't prepared any of these answers, so for the questions you guys fire off, might be challenging for me to answer in a live video, but we can at least post answers if I can't do them on the actual live video. So your job is to sit back and see if you can win something, probably learn something, hopefully, and ask questions. Doesn't matter how silly the question is, safe space, you can ask anything you want. Worst thing I'll tell you is no, I'm not answering that. So, in terms of what we're giving away, we've got 3 different swag packages. The base one, Josh, do you know what the paperwork is for them over here?
It's not, I'll go grab it.
Oh, okay. Josh is going to grab the paperwork so I can explain what we're giving away. The big cool thing that we're giving away is the big winner gets an actual set of nickel-plated dimple dies. So these are our nickel-plated heat-treated dimple dies. Smallest set we sell is this little one. It's a 3/4 and 1 inch, I think. So, thank you. So the prize we're going to give away, we've got a first prize. It's a quick ID set of nickel-plated dimple dies made in the USA. Small set we have. Those are $109 on our webpage. And then a sticker set and a long sleeve shirt, or sorry, short sleeve shirt. Second place, we're going to do the hoodie and a sticker set, and then the third prize we're going to do just a shirt and some stickers. So just so you guys know, before the end of the video, during the video, we'll be giving this stuff away. The hoodie is not our base Gildan hoodie. It's one of our nicer ones. These are made by independent clothing company. The screen printing on them is really, really crisp and beautiful. And of course, this is our full send one. If you're going to send it, use a rug fab to bend it. Kind of funny and clever. Same thing.
Dude, that's try something in the way.
Oh, it is? So that brings me to answering the first question we have. Josh is going to be showing you guys exactly what's on the tube capacity chart. We had only 1 question submitted on our webpage prior to this video going live. And so if you go to our webpage, just go to the tech section. And if you go in the tech section up at the top here, there's a tube capacity chart. You just click on that link, and it's going to take you to this big table. And this table has the ability for you to choose your machine's capacity. And you can, of course, look across the top of this guy is all of the alloys. So you've got aluminum, you've got titanium, stainless steel, carbon steel, DOM, which is, of course, one of the carbon steels. You've got 4130 chromoly, which in our experience bends just like DOM, and it matches up in our capacity chart with it, which you can see in the capacity chart. And then right along the side, along the left side, you have all the different dies, OD by CLR. So a 1.5 by 4.5 die is a 1.5 inch diameter tube bent on a 4.5 radius. It will give you the minimum and maximum wall thickness for every single one of those dies. So the gentleman who asked us said, do you have a table of the minimum bend CLR for each material? Yes, this is that table. We've got it made, and it's selectable based on your machine's capacity. So if you have one of these machines that's just barely behind the screen that Josh is showing you right now, these are XHDs, M600 XHDs. So Josh could have picked that instead, and all these numbers would be bigger for the maximum wall thickness. So that machine, for example, maxes out on 1 3/4 at solid bar. It can bend actually solid bar. And I've got a piece just off camera to show you guys if you want. That capacity chart is how you know you can bend stuff like this. So this is a really, really massive chunk of solid steel that we bent. So, of course, bent at room temperature. We don't pull any tricks. If we ever do pull tricks, we always tell you. So Josh will probably close that unless you guys have questions about it. And then he's going to run right back through here, and he's going to fire off any questions you guys have for me.
I saw one question.
We're back full screen again, right?
Someone asks, what's the best die or package to start with?
Best die or package to start with. I don't know if you guys saw this thing, so while I'm answering that, I'm just going to show you guys what the screen printing looks like, because I don't think it showed it before. There it is. Yeah. So, someone asked the best package to start with. It depends what you're bending. If you go to the Bentec section on our webpage, which I'm not going to throw up on the screen, we explain how tubing benders work, including mandrel benders, ram compression benders, which this is not. And we also explain the most common tube sizes for each project. The most common tube size for that project is the size you want to start with. So for side-by-sides and off-road stuff, that's going to be 1 3/4. If you have to pick one radii to go with the 6-inch, not the 4.5. Basically, when you're picking your radius, multiply your OD times 3. So for 1.5 times 3 is 4.5. That size or bigger. 1 inch times 3 is 3. 3 inch or bigger for your CLR. So on a 1 inch, we offer a 2.5 and a 3.5 and a 4.5 and a 6. Those bigger ones are for thin-walled stainless, doing bigger radii, stuff like that. The 2.5 is really tight, not generally my first choice. I'd go with a 3.5 in that case. So that should help explain it. If you're doing like go-karts and stuff like that, you're going to be in the 1 1.25 range for diameter. And again, the CLR, multiply your OD by 3, round up if you want to go up. If you're doing like boat wake towers and stuff, or handrails, those generally fall into pipe. They can be aluminum, stainless, usually those alloys. You're going to be in the 1 1/4 pipe range, which is 1.66 OD, just barely bigger than 1 5/8. But those are really the sizes you're going to be going with. If you're doing a race car, grab the manual for the sanctioning body. NHRA, SFI, NASA, SCCA, those kind of things. Grab the book from those guys. They will tell you what you can use. They will not just let you build whatever you want. NHRA and many others use 1 5/8. They have requirements for mild steel and for chromoly. So that's the best one to start with. My favorite second size is always 1 1/4.
Bag Winnebago asked, would it be in the future guys to bend square tube or rectangle box tube if there are already square?
Okay, so yes, and I actually have one just off camera. I'll grab it. We have plenty of dies to bend square tubing. This is a clamp for one of our square tube dies for 1.5 inches. So obviously, just like a round tube die, but it's got a square groove cut in it. And this is a piece of 1 inch by 1/8 inch wall aluminum. We do not have any dies for rectangular tubing. So rectangle being the non-equal sided rectangle, square. So we don't have those. But we do have them for this one. This is a piece of, like I said, 1 inch, and it's bent really, really nicely. The deformation is really minimal on it. This was a 4.5 inch radius. So that ratio I gave you where you multiply the OD by 3, round up, for square, do that times 4. So 1 inch, you're going to want to do with a 4 inch radius or larger. 1.5, you're going to want to go with a 6 inch radius or larger, and so on. So that'll really help you in getting a die that'll do what you need. Again, the capacity chart we showed at the beginning of this video is your friend for picking dies. If you've got an application and you want to pick a die, go to the capacity chart. It will tell you which die to pick.
So this way is asked, how much strength is lost if you bend 1.5 thin wall DOM on a 4.5 CLR and isn't kinking but it's deforming a tiny little bit?
So 1.5 inch thin wall on a 4.5 CLR. Our spec minimum is 105. We do have a customer who bends 0.95 on a 4.5 radius. I would consider that thin for that die because the radius is tight. It's right at 3D, meaning 3 times the diameter for the CLR. 4.5 radius, 1.5 diameter, 3 to 1. And I would expect it to deform substantially. That's why it's not within our capacity chart. I would say probably 10%. So you're going to go from 1.5 inch on the tube down to 1.35, 10%. You're going to lose a lot. It's ugly. But if you use a mandrel, that is completely alleviated. So you take a mandrel and you put it inside the tube while it's being bent, and it holds the tubing open. So as the tubing tries to collapse, it just goes up against this thing and holds it open. We've got videos on our YouTube channel that are studio edited videos that show the mandrel in operation and help explain what it does and why it works. But I'm assuming you're talking about without a mandrel, bagged Winnebago. So that's kind of the limits and what we expect to see. The 6 inch radius, of course, does a much better job and can bend 083 with very good success.
Someone asked, what's the benefits of our bender versus the JD squared?
Benefits of ours versus JD squared. So this gets asked constantly. JD squared makes a fantastic product. They're a good company. There's nothing inherently wrong with their bender. Their bender bends horizontally. If you guys haven't seen it, it's that ratchet thing with all the holes in it. So you pull on a lever, it bolts to your floor, and it bends around horizontally. Ours bends vertically, which in most cases is an advantage. If you look at motorsports applications, you've got 4 to 5 feet between bends. So your material is going to go 4 to 5 feet above the bending plane in the machine. So a little bit above my hand here. I bent my first roll cage in a 2-car garage, and I didn't have to go outside to do it. So residential garage. So vertical safe space. This one is self-contained hydraulic, whereas the JG Squared is not in most cases. I'll explain. But it pushes from the frame to another place on the frame. So you can pick this whole machine up and take it with you. So this is not mounted to the table. It's very heavy because it's an XHD, but it can move wherever you want it to go. The JG Squared in its cheapest form mounts to the floor with concrete anchors, and so you will be having that in a fixed location and a fixed swing place for the tubing. So if you fold a 10-foot stick in half, it'll take a 20-foot diameter circle to bend that in all the different orientations you'd likely bend it in. Other than that, they're both rotary draw benders. They both make good bends. They both have good support. They're both supported by Bentec, and they both have a very wide range of dies. JG Squared does make some of theirs to order, stocks a lot of them. We stock every single one of ours. We do custom make them if you have a custom die and you ask for a 110 millimeter die on a, 361 millimeter radius, or well, I don't know, something weird. So we can make those. They're expensive and we make them to order. Other differences, ours can make S-bends. None of the options from JG Squared can. S-bend is when you make a bend and right after it you have a bend going the opposite direction. So that's one of the claims to fame of the M600 line of tubing benders, is because the clamp is isolated from the bending die, which is the piece inside. And these guys, it actually bends the tubing. You can bend with the clamp block upside down and in the wrong hole and all kinds of weird stuff, and you can totally just clamp in the middle of the bend and bend right around the die still with absolutely zero spacing between the bends, back to back touching, making an S shape. So that's a really cool thing. But in terms of differences, main thing is the layout, since they're both rotary draw tubing benders. That's really most of it. I know it's a long answer. Hope that was a good one for you.
We have someone asking, what's the best way to measure the beginning or end of a bend after you remove your clamp block from the tube?
Best way to measure the beginning or ending? I can show you that. I'm going to show you on a piece of square tube. Normally this would be done on a round tube, but it's going to be the exact same process. Take yourself a straight edge, put it up against the tubing. The first place you see light, which happens to be like my eyeball right now, right there. Anyway, that's where you're going to put a line. So I'm going to take this, and right where I see light at the very first point, I'm going to put a line right there. The very first point where I can see light in between the straight edge and that tube. That's the start of the bend to me. And in my case, I think I was off by a little bit. So really, I think it's right there. That's the start of the bend. You just find your point of tangency. So this is tangent to the bend, right at the place where it touches it. Tangent point is the start of your bend. And if you're setting up in Bentec, tangent is also the name Bentec uses for measuring from the start of the bend instead of measuring to the middle of the bend. The middle of the bend is very hard to find. So set yourself to tangent in Bentec. And then I will use the same terminology when I teach you guys to hopefully keep everything consistent.
Dylan Ray asks, have you had any discrepancies with a 112 degree bend versus what Bentec computes? I follow the spring back and how you guys explained by letting off the ram and pumping it until it's hand tight.
I haven't done a lot of over 100 degree bends in Bentec, so I have not found any discrepancies there. One thing you can check is the degree sticker on our machine is a piece of vinyl, this piece here, and it can be stretched during installation. So one thing you can do is take one of our angle cubes. This one likely has no batteries. Oh, it does have batteries, even better. Take one of these angle cubes, and it's going to read your angle. And you can take this and set it on the machine, zero the machine, zero the angle cube, and then start bending. And then when you get to 90, this guy's going to start counting at 0 again. And then it's going to get to 10, or 80, I guess. Anyway, when it gets to 80, that means you're 10 degrees past 90, which would be exactly 100. 90 plus 10 is 100. So this is a good way to check, or any other protractor, any other digital angle indication system. We sell these on our webpage. They're around 40 bucks. So you can just put this anywhere you want to on the bender. Here is a fine example of the place you can put it. And when you bend, you can check your degree indicator to your digital angle cube. And that's a good way to see if your degree indicator on your machine is effectively lying to you because it got stretched. We do sell those so you can get another degree indicator, and you can mount it slightly further out to get fewer degrees out of it, or stretch it to get more degrees out of it. So you can fine tune that. Generally, it's going to include reapplying a sticker. So.
Someone asked, what made you want to design a new bender?
Oh, boy, that's a great question. I wanted to design a tubing bender because I was shopping for tubing benders. Now it's been about 12 years ago. I had a rock crawler, which you guys have probably seen. It's a Toyota 4Runner. And I wanted to build a roll cage for it, an exo cage, in fact, and bumpers and rock sliders and everything else that you bend out of tubing for a off-road toy. And I kept seeing these tubing benders for sale for like $300 brand new, and I was like, oh yes, I finally found a good deal on one. And then you go look at it and it says, oh, well, the die's separate. And you're like, oh, no big deal, I can get the die, and the die is $363. Like, cool, well, we're still well under $1,000. Then you go out the pedestal mount, and at that time the degree indicator, which was also a separate purchase, and then the bar, which at that time was also a separate purchase. And then I was renting at the time, and I looked at the concrete anchors, and redheads at Home Depot were the concrete anchors that expand and grip the concrete to mount this pedestal to the floor. They were, I don't know, $28 for 4 of them, and then you had to go rent a concrete drill, which is another $45 or something like that. And it all added up and ended up being over $1,000, including shipping. And I had to drill holes in the concrete floor in the place where I'm renting, and I'd have to fill those holes when I left. And that location was also where the vehicle that I was working on was being stored. So I had to take the vehicle out to work on it, which it wasn't always running, of course. So all of those drawbacks and the feeling of, oh, I finally found a $300 bender and now it's $1,000 is the reason why I designed one. Because at the end of the day, I didn't want one that was mounted to the floor and manual that was about $1,000. We now, after all the steel market increases and 10 years have gone by, these guys, the base weld together kit with shipping hydraulics, they're around $1,000 now. Back when we first launched the company, they were $700 or so. So it's changed a lot with the steel market. So my story isn't quite current in terms of pricing, but it's those features and the value that kind of led me to want to design one. And I originally designed it for myself so that I could have one. And being a mechanical engineering student, all my friends were gearheads, and they were saying, Josh, interrupt me if this is a boring story, by the way, if you got too many other questions. So they were all saying, hey, I asked a few of them for input, and they said, oh, that's cool, but can you make 2? I want one too. I like the way this is going. And so by the time I was done, I had a prototype that did not work, and I had like 4 friends that wanted them. So I modified the prototype, got it working, ordered 10. Long, really funny story with my wife on how we ended up ordering 10. She thought I was ordering 1. I gave her the unit price, so it was pretty funny. But we ended up getting through it, sold them all at a show, and sold some to my friends, and kept on going. Chris Schoolcraft, I doubt you're watching or anybody knows you on this video, but he was one of the first people that ever bought one of these machines. I think he was number 2 or 3 that we ever sold. And he bought the first non-inch and 3/4 die. When we first designed this machine, it was only for inch and 3/4 tubing, because that was the only thing I thought mattered, because that's the off-road bread and butter. And so now we've got dies from 1/4 inch up to 2 inch, and metric, square, pipe, all of them. But that was what led me to design it in the first place, was just, I would say, a perception of insufficient value in the industry. I just didn't see that there was enough for my money and tools. I wanted to get more or spend less, and I couldn't do either. If I got more, I spent more, and if I spent less, I got something imported of vastly inferior quality to the offerings at the time on the market. So
we have 2 related questions, kind of.
Okay.
First one is, how do you cure the clamp block slipping?
Okay.
The other one, I'll ask the other one in a second.
And guys, let me know if you can't hear Josh reading the questions. I'm not repeating what he's asking me. Usually we can hear just fine with this mic we have on this camera. So someone asked, how do you stop the clamp block from slipping? I'm going to grab a clamp block and I'll explain.
And someone asked, oh man, I just lost it again.
So this is a clamp block, and if they're slipping, it is not because you don't have these, not usually because you don't have these weak grade 5 bolts tight enough. This is kind of like a shear bolt and a tractor attachment. It's meant to break. It indicates that you have a massive problem on your hands that does not relate to the bolt not being strong enough. If your clamp block is clamped in the machine, it's bending tube. Hydraulics are pushing it this way, clamps out here, and it's bending, and it's going to be pulling like this. If it slips down the tubing, it's going to cause a bunch of problems, decrease bend quality, might bend pins, you'll have some issues. Call us, we'll help you figure them out. But if it does slip, you will see a bunch of scratch marks in this guy. They'll be scratched this way, as if I was scratching it right now with this bolt. You want to get rid of those scratch lines and keep your tubing clean. So what you're going to do, before you do anything else, get the bent tube out of the machine, get a straight piece in there. You're going to take some 200 to 300 grit emery cloth or sandpaper and just rub in a circle. I usually just have the clamp block assembled, and I just rub it in a circle. You want to do that until almost all of the lines going through from slipping are gone. Those lines going the opposite direction on a micro level are going to interlock with all the grippiness that's in smooth tubing, which there is enough of. Then lacquer thinner. Lacquer thinner, if you don't have that, acetone, if you don't have that, brake clean, something that evaporates and cleans. Do not use WD-40, do not use Simple Green, it's soapy and slippery. Those evaporative cleaners like lacquer thinner, just lacquer thinner this real quick with a rag. That same rag you just used, you can just clean the tubing with. If you do that, honestly, just a little regular 6-inch wrench and comfortable force by hand is plenty to tighten the clamp block bolts. You will not need to try to break these to get them to tighten, even on 2-inch.
The second question was, how do you calculate spring back and what do you do to compensate?
Calculating for spring back. I'm going to default this question to another video, Bending 101. That video explains spring back better than I can without the machine running, but I can tell you right now, what we do in that video is we bend the tubing, or we just advance the machine until it's set to 0. You know, get it tight so the pins are snug, which means the machine's about to bend. We then zero our degree indicator. Then we do our bend. If we're doing a 90, we're going to hold the trigger until it's bent to 90, so we'll see the degree indicator pointing at the 90. That means the tubing is at 90. As soon as you let off the hydraulics, you see everything kind of, go back. And if you start bending again, the pin will get tight before it gets to 90 because the tubing sprung backward. So you measure that. As soon as you advance the machine till that pin gets snug, you read off the degrees. You're going to be at 83 to 86, 87. Take 90 from that number, or whatever the absolute value of that subtraction. You're going to get 6 degrees, 5 degrees, 4 degrees, whatever that number is. The difference between 90 and what you actually had, that's your spring back at that bend angle. So at 90, you're going to have 5 degrees of spring back, for example. If you bend to 180, you're going to have more. If you bend to 35, you're going to have less. It's a curve. So don't just write down the side of the machine, spring back is 90. It depends on the alloy, the outside diameter, the wall thickness, and how far you're bending. So Bentec has tables that can store all that data. You don't have to get that fancy. The most important thing to do, if you only bend 1 3/4 120 DOM, it's going to be pretty easy. Get your spring back for a 35, a 60, a 90, and a 120. If you're real simple, write that down in Sharpie on your powder coat. You can always wipe it off later with lacquer thinner or acetone if you want, but that will be enough numbers. You're going to have, 4 degrees at one of them and 5 at the other. If you're between the two, just go with 4.5. It's close enough. So that should be good on spring back.
Someone asks, is it better to get Bentec? He uses SolidWorks and Fusion 360. He's going to start building space printers.
So, as of the time of this video, SolidWorks starts at about $4,000. Fusion 360, I think it's cheaper, but not by a ton. I think that's the Autodesk version of that same solid modeling CAD all-in-one system. Bentec's like $300 for Bentec Pro. What Bentec does that the other systems do not do, and they do a lot, and I'm a SolidWorks super user, I know, they do not make manufacturing instructions. So what Bentec will give you, and by the way, this is the kind of question that's great to submit ahead of time because I could have brought sheets of paper from Bentec and shown you, but what Bentec will give you is manufacturing instructions. So what it's going to do is it's going to say, take tube 1 and cut it to 58 inches. And then take tube 1 and put your clamp block, remember this guy, well locates the tube in the machine, and put it 16 inches from the end. And then start bending. That's going to put your bend 22 inches from the end on a 6-inch radius, which is the information that's right on the bender here for your bend offset. But Bentec knows what the bend offsets are in this machine. You just tell it that that's the die you've got, and it automatically knows. So Bentec does some really cool stuff, does help reduce scrap. One of the coolest things it does for people who do not have Autodesk Fusion 360 or SolidWorks is it's not $4,000, and it's $300, and it does a lot of the same stuff. Basically draws your tube, allows you to show it to customers and make sales pitches to your customers based on what you've got, make changes on the fly, save designs, edit those designs, save them off as copies. So you've got, Razor 4-seater cage, Razor 2-seater cage, and then Razor cage with extra headroom for the guy that's 6'8" and wants to race 2. Really fantastic software for doing repeat similar work or repeat same work and seeing your changes. If you've got a slight tweak to make, you can make the slight tweak and it comes out really nice. Those tweaks and percentage adjustments of width, height, depth are not really feasible within SolidWorks. SolidWorks is really powerful for a lot of stuff. I use it daily, but it does not shine in tube manufacturing. So that's where Bentec comes in. If you get Bentec SE and the $400 SolidWorks communication module, I know it's a lot to swallow. It's $1,000 worth of Bentec. You can go back and forth and reverse engineer parts in Bentec from SolidWorks and vice versa. So you can actually take tube you designed in SolidWorks, bring it into Bentec, and it will make all the bends and features in Bentec. And then you can actually edit the part and its individual bends and width and scaling in Bentec. So that part's really powerful, but you do have to pay for it.
Someone asked for a 6061 round tube, doesn't need to get annealed before bending, to prevent cracking.
Great question. Annealing or detempering 6061 T6, the aircraft grade aluminum that everybody loves for its strength to weight ratio and rigidity and machinability and weldability, is a benefit. If you can anneal it, there's a few old school like soot or Sharpie methods where you turn the tube black with either pure acetylene out of a torch or a Sharpie marker, and you heat it up until that blackness burns off. That's about going to detemper down to T0. It will time harden back to a lot closer to T6 after that process, so you'd want to do that the day or hour that you're going to be bending it. I wouldn't bend it while it's hot still, but that will make it bend better. It's going to make it more ductile. Our capacity charts for aluminum all cover 6061 T6, which is included in the notes, and they all cover it bent cold at full temper. So the stuff does like to crack. This same application, 6061 T6 1/8" wall in a 1 1/4 size, not the 1 inch this is in my hands, on the same radius, 4.5, which would be 9 center to center for a 180, will crack by 15 degrees. I've done it, I've got some that I've bent to, 10, 12, 13 degrees, and then welded to stuff that's not a life-saving structure. It likes to crack. If I'd have detempered it, it probably wouldn't have. I generally don't have the time when I'm experimenting to do that kind of stuff, and it's really inconsistent, so I try not to set up our capacity charts and our like walkthroughs and tips for our customers in a way that prevents them from a lot of variability in their results. So, but to answer your question, yes, it's better to detemper it. Big companies can buy it in T0, and then they get their stuff done and then they send it off to be treated back to T6. Smaller people, in terms of buying power, have to do it the shade tree mechanic way with a torch and heat it up until the blackness goes away from whatever you applied, and that's roughly T0. I haven't done that, but I've read about it.
Someone asked, what are you designing next?
What are we designing next? Tough topic for me. We are designing stuff. We will be presenting it, and I can't really talk about it. We've had enough people trying to copy what we're doing that we don't share it much anymore. So I'm really sorry to tell you this, but that's a no. Too many people have tried to take what we're doing and do it before we do it or right after we do it, that we pursue patents and intellectual property protection and other safeguards prior to releasing to the public. So we're currently innovating tube bending stuff and other shop tools, not just tools that are stationary. So some tools that have moving parts. That's the stuff that I can tell you. And they're going to be really cool. And the plan is to release them this year, but we got pretty busy, had some turnover, so that slowed things down a little bit. We also had some parts to come in not to print, but they will be released soon. Probably Q1 2022 we'll have final pictures of some of those things. Some of them have already been shown in some pictures in various places and kind of sprinkled in, but we haven't described them very thoroughly yet.
Someone asked if we're involved in any motorsports operations, and do we sponsor racers that build their own equipment versus buying it?
Build their own equipment. If you can answer quick enough, do you mean build your own equipment as in
build their chassis?
Cars? I'm guessing cars. If you mean tools, probably not. We do sponsor some racers. The challenging thing with racing is 25 years ago, before social media was a big thing, you could just slap someone's name on your car. You could put, Hoosier and Tanner's Tires and, Bob's, grain harvesting service on the side of your car. And there's a lot of people at the track, not necessarily just watching on TV. And so they would see your car going around, and it was a big deal. You got on the podium, you wear your hat. So, oh yeah, thanks to Bob. You take your hat off, put the next hat on, thanks to Hoosier and everything else. Those benefits have diminished a lot because of media coverage and social media. And so the physical presence of sponsorship isn't quite the same as it used to be. That being said, we do still sponsor some competing drivers. Dangerous Enterprises races NASA ST2. It's not a widely televised racing class. It's a road racing, wheel-to-wheel road course racing class. And they race a GTR. It's a sweet card, but their whole cage with our bender. They documented most of that process. They've been great to work with. So that's one fine example. There are a few others. I'm drawing a blank for some reason. Josh, who are the two Pikes Peak drivers?
Oh, yeah.
Sean Bassett is
Sean
one of
Bassett,
them.
Yeah, you're in Pikes Peak.
What's his business's name?
Attack the Clock Racing.
I'm so embarrassed, I forgot. Attack the Clock Racing, Sean Bassett. He was one of our very first customers, actually. Way back in the day, he bought H1 wheel centers for his Range Rover. And he has our tubing bender, he's got our notcher. He's building for customers, he does custom carbon fiber work. Really cool shop, lots of intricate stuff going on. And he has one of the coolest Z-cars I've ever seen. I think it's only Z-car from the firewall to the back fenders, but the rest of it's all tube. But really fast. It's around 1,000 horsepower V8 that's in it, and it's straight time attack, built for Pikes Peak. Really fast car, really cool looking car. Lots of custom air and duct work in the front. So we sponsor him as well. But we always have to analyze sponsees on a rate of return basis. Being a relatively small company like Road Fabrication is, we can't just like dole out a bunch of sponsorships like Rockstar Energy does, just see who grows fruit on the tree. We have to make sure that we can get that first. So sometimes they'd be a baby sponsorship where we kind of have milestones and payments or something like that. Other times in bigger cases, if someone's got a big YouTube following, they've got 100,000 subs, they've got 500,000 on Instagram, that's immediately valuable to us. If Ken Block, if you're listening, we'd love to sponsor you, but obviously you guys aren't Ken Block. So we have to look at those things with a grain of salt. If you've got 38 subs on YouTube and you race circle track at the local track, call us. The worst we'll say is no. But it's kind of challenging to sponsor circle track guys because at some point we have to find someone to sell the material or sell the tools to as well. Everybody buying our tools is racing or playing, and they've all got some level of exposure. So.
I got 2 questions we got paired together.
Awesome.
We're supposed to do up the dies for bending, and we have someone who lives in Minnesota. It's really cool. So he's asking about bending in cold and things to look out for.
Lubricating the dies depends. If you're doing, I'd say yes, but very minimally. So the best thing to do is light machine oil, like engine oil or gear oil, on the pins where they pass through the machine, where they pass through the dies they pass through. Like this one has a second pressure roller die, which again says right here, don't use on thin stuff. Please don't put dies back here unless you're bending something really heavy duty. Our capacity chart will tell you when. I'm only mentioning that because I'm touching that part of the machine, people will see it. Wouldn't put a bunch of oil on this. It's rolling with the material. Same thing with the bending die. Tubing doesn't ever stick to these. It can stick to the bending die. The big one, it goes in the middle and actually gets the tubing wrapped around it to bend. That one's not a bad idea to put a light coat of oil on it, once every 10, 20 bends, and then clean in between those oilings, before you apply new oil. So that's really the places where I would oil it. The risk when bending or oiling the bending die is if you're moving the tubing forward in the machine between bends and clamping, you're going to get oil pushed into your clamp, and then it's going to start slipping. It's going to get those scratch marks in it, and it's going to continue to slip, and you have to recondition it. That's the risk of lubricating any surfaces the tube touches. So I usually bend dry, but you can lubricate them. You have to be really careful about contaminating your clamp block with lubrication.
We have one guy saying, is this a lot harder to bend than mild steel? And when does or if preheating ever become necessary?
On to that one, Minnesota and cold bending. There's a ductile to brittle transition that occurs in all materials. Some of them do occur relatively close to the freezing temperature of water, which would be experienced pretty readily in Minnesota or Michigan. You just be careful of that. If you're bending and the tubing cracks, you're in a ductile to brittle transition area. If it's ever in the teens, I would definitely want to have a warmed up shop or warm the tubing up so that it's comfortable to touch and feels nice, but not hot enough where you can't touch it because that's going to start to cause other things to change. That's kind of the level of heat that I would use, and I think that's kind of the level where I'd start doing it. I don't think around 30 or 40 it would really be necessary, but if you can, anytime it's comfortable for humans, it's comfortable for tube bending. I would try to get your shop warm if you're comfortable. It'll help with all kinds of things, including your material not being brittle. But if it doesn't crack and it bends fine, no big deal. You have to watch for micro cracks on aluminum. It can crack without being visible. The other question we had was about stainless and if it's harder to bend than regular steel, and when was it preheating was necessary on that. We don't preheat anything. We don't recommend it in terms of just bending regular materials in a regular shop environment at regular temperatures, like anywhere around 20 degrees C or anywhere around 60, 70 F, 50 F. Stainless steel is more difficult to bend, not because it's stronger. It is weaker than almost all carbon steels I've dealt with. It is more likely to wrinkle. The chromium that is in it, I don't know if that's what's doing it or not, but something makes that stuff a lot more flimsy in terms of just buckling. And so when you get The compression on the inside of the bend, it likes to wrinkle. It does not like to crack on the outside like aluminum does. So in that tension on the outside of the bend, it doesn't usually fracture there. When you get failures, it usually wrinkles on the inside. So it definitely does wrinkle a lot easier. If you look at our capacity chart, we've got a separate column for stainless steel, and generally your one wall thickness up on the minimums for all of those applications on our capacity chart that we showed earlier at the beginning of this video. And that's why, it's because it likes to wrinkle. So it's a little more challenging for that. It's nice for exhaust because they don't rust from the inside out. But thermally, I've heard from some people in the industry that know they're talking about pretty well that mild steel is better for thermal reasons than stainless. And so if you can afford to replace the exhaust system that often, which isn't terribly often, mild steel that's ceramic coated is going to perform much better than stainless in some thermal environments. So.
Someone asked, what are the difficulties of designing a bender?
The difficulties of designing a bender. That's a challenge. The trade-offs, I'd say, the biggest challenges. Trade-offs of cost and features. You know, people used to say, well, if it's $1,000, why does it come with a piece of copper for the degree indicator? You notice both these machines have these pretty powder-coated and then formed degree indicators on them. Those, of course, aren't part of the basic bender. We try to keep as few features as possible so the machine performs, but is affordable to purchase. And then we've got a few options and upgrades you can add to make them, you know, maybe work better, mostly be more comfortable to use and nicer to look at. So that's the biggest challenge, is the trade-offs in terms of value and features. Another one is another kind of trade-off, and that is trading off of optimization for various markets. So like I showed you, that big piece of solid steel that we bent, this one right here, you can't have the pivots crazy close on the machine. You know, if our clamp block was like touching the die, I wouldn't be able to do this. It'd break. The clamp block would just snap off. And this is not used by a lot of people, but people want to know they're not going to break the machine. So this is very useful to be able to do. Similarly, if we made the machine able to bend this thin stuff in its basic form, it'd be very, very, very expensive. This is 2-inch 065. And this can be bent with our mandrel attachment, and I don't know of another machine that can do it for less than, say, 40 grand. And you can get a machine from us to do this for like 4,500 or 4,000, depending on configuration. But trading off those kinds of features and saying, like, are we going to please just this crowd or just this crowd, or how do we please both of them, and what do we trade off in that case? Those are the big challenges. And you know, if you don't do that well, you'll find yourself with like 10 or 15 models of tubing bender. You'll have one that's really shines on exhaust, and one that really shines on go-kart frames, and one that's good for off-road stuff, but they're not all the same machine. So that's the problem.
Someone asked, what's your next truck build?
Next truck build. I have dreams for myself of building a really cool, like adjustable ride height, kind of variable, like big tired portal axle vehicle carrier thing that would basically be a rig that would carry the 4Runner that I built. But this would require hundreds and hundreds of my hours, so I don't know when I'm going to get to do that. But that would be my next truck build. Car build is also kind of a segue. I don't know that either. I have some desires to build like a tube only thing, like an exo car with no body underneath, just exo only. Maybe some slight body skins, or a sand car, you know, a sand rail, but two-wheel drive sand car. Basically just be a, you know, sweet dune, hill climb, fun, big paddles, lots of power rig. But again, it's the time really limiting me. So.
We have 2 questions for the 3-inch bender.
Questions on the 3-inch bender. So you guys asked what we're working on. I said, no, we're not telling you. Future questions asked in the same video, this one. How's the 3-inch bender coming along? We are developing a 3-inch bender. Lots of work we're doing now is laying the groundwork for that. It would not be this machine. We're not going to put 3-inch tubing in the M600. It would be a different machine. It's going well. It's still going slow. We're still laying all the groundwork and protections and doing patents and that kind of work and protections and being very careful who we share information with on that project. So obviously the public knows we're working on one. The purpose of that machine is to be able to capture a even broader automotive fabrication market segment than this one does, and get into the bigger stuff for, you know, boats, greenhouses. This one does boats a lot too, but boats including boat exhaust, greenhouses including the greenhouse frames for 2-inch pipe, more variations in terms of the geometries the machine can produce, and of course, what everybody really wants is 3-inch mandrel bending. If you can do 3-inch mandrel bending in your own shop, right now the cheapest machine that does it is about $80,000 without tooling, without rigging, without installation, without training. That machine may come with training, but the tooling's gonna be $5,000 per die set. Rigging's gonna be $5,000. You're gonna have probably dedicated power put in your shop for that machine. That machine's going to be $100,000 by the time you get it running for 3-inch. We are very aware of that. That's basically the price target. It's like the cheapest machine you can get right now that'll do 3-inch reliably at good ratios and performance. And so that's kind of what we're shooting for, is being substantially lower than that. Milling of this machine's around 1,000, give or take. These XHDs are closer to 1,500, 1,800. Not gonna be anywhere near that, 3-inch med. So if you have a price idea or you want to be on the list for updates for that project, we haven't sent out any of those updates yet because we don't have anything publicly shareable at this point. Email us and we can get you on the list.
We got Garage Guru TV in the house.
Garage Guru TV is here.
Asking, how did you get the results of those bends that you posted on Instagram?
Yes. We can't tell you, unfortunately. So, do you want to run and grab that stainless piece from upstairs?
Yeah,
I can show them that. We have some other results that we can share with you, but so Garage Guru TV is here. They work with in the SEMA Young Guns program where they compete with, he might post an answer for me, but I think it's like age 20 and under or something like that. It's young people, like barely adults and older kids who are building stuff for SEMA, and you have to be one of the young builders to compete in that program. So it's really meant to get youth interested in that, in fabrication. It's a really cool process they do. And Garage Guru built a couple really sweet builds. They did I think a E30 M3 was one of them. And he asked how we got the results we posted. We posted some bends that were similar to this, but better in terms of performance. This one's 2.4% deformed, which might focus and might not. So this bend is pretty good, but it's not perfect. It's got a little bit of a defect here in the beginning. You see a little wrinkle close to my face. Not ideal. We got one with basically none of those defects and 0.2% deformation. This is 2.4. This one had 0.2. So we're talking 4/1000ths of an inch, comparing this measurement between my fingers to the nominal size of the actual material. Which, if you go to roguefab.com/tech, there's a tube bend quality calculator. We're going to explain to you how to take this measurement. I know, it's very elementary, it's very simple, but we'll show you with pictures how to take this measurement, how to mess this measurement up so you don't do it wrong. And then, of course, you can take your OD, and then your bend radius, and your wall thickness. You just put all those numbers in, they'll give you your wall ratio, the D of the die, like a 3D die is three times the diameter for the bend radius. Tell you how hard the bend is to make. We did ones more difficult than this in terms of ratio and some other stuff. And that is what Garage Guru TV is asking, is how did you do that? We did it with our mandrel bender. We're doing some innovation on that product right now, and I can't share really any of the details on that, but it's stuff that fits with the current mandrel we offer, but it's not the exact same componentry that goes with it. So someone could buy our current mandrel, do some stuff, get results similar to what I just showed, if they're very good at it and take their time. And they could get better results if they wait until we have other things to offer, assuming we sell them. There's not an actual guarantee on that. So this is a piece we bent recently. This was kind of fun. There are no welds in this piece. This is first time we've shown this, and we said in one of our posts that we were going to show something new that we've never shown anybody before. This is that thing. This thing's super, super light. That's because it's 2-inch 049 wall stainless. So this is stupid thin, is what I would classify it as. If you build turbo manifolds, you probably don't want to use this. It's not really sturdy enough to hold a turbocharger while it's at temperature. So, but it's tough. It's a great test. And there's some major defects in some of these bends. You can see some huge wrinkles down here. But other parts of this tube have pretty nice bends. I circled some of the wrinkles over here. They're, moderate. They're not real bad. But this is also a tighter radius than the last piece I showed. This is only a 5-inch CLR. So it's a very tight bend. You can see behind me here, this now chubbier, slower looking bend. This is a 6-inch CLR. This is thinner wall, stainless, and a tighter radius. It is massively more difficult than this to do this. Even though it looks relatively similar and the performance is about the same, it's a big deal going to stainless, that higher wrinkle-prone material, the tighter ratio of the bending radius. This is a 5-inch radius, as I said, and of course the thinner wall. Going from 065 down to 049, we're about 20% thinner on the wall, we're about 20% tighter on the radius, and we're about 25% more difficult in terms of bending, going from a carbon steel DOM 1020 to a T304L stainless. So this is a fun one, but unfortunately for the guys at Garage Guru TV, can't tell you the exact specifics of it. It will be public at some point, but not now and not likely in the next 6 months. So.
How much does deformity affect the strength of the tube?
That's a good question. I have an answer for you. So, way before the mandrel, we had some bends on thinner walled material that were deformed like 9%. We're talking like 1 5/8 083 chrome moly, like 9.5, maybe 10%. Depends on a lot of factors, but they don't look great. The outside of the bend's kind of flat, and so I wanted to know, is this still safe? So I did some finite element analysis on it, some simulations in SolidWorks, you know, that expensive software I was telling you guys about, and you can't do most FEA in the cheap of SolidWorks. You have to spend even more money than that. But I compared that bend just loaded up with forces in a couple different directions, how much load it could take, just one bent piece of tubing deformed 10%, which we had to model in SolidWorks, to a piece of tubing bent with, say, 5 or 6% deformation. And 5 or 6% meaning how much diameter it loses. So 1-inch tube, that'd be going down to 0.940, losing 60 thousandths of an inch, 0.06, which is 6% of 1 inch. That loss difference between going from a 6% deformed bend to a 10% deformed bend changed the overall load capacity by 2%. And I'm giving you a whole bunch of numbers here. So we're talking about doing what our machine produced, which is 10% on that one application, to what I got from a Bailey or some other machine, which was like a 5 or 6%. I think it was 6%. I compared those two in software, and the difference between those two in terms of their load capacity, assuming they failed in the bend, not in a straight part or a weld where cages usually fail. If one would hold 1,000 pounds, the other one held 980, 2% less. Not super significant. I would say not going to make the difference between saving a life and taking a life in terms of a vehicle rolling over and you know, going to a yard sale. But worth considering, worth debating. Fantastic question, and I do still have a white paper on that if you want it. It's like a college type of write-up on like a dissertation on what we found and how we analyzed it, how the loads were simulated, and what software was used, and how the modeling was done. If you want that, to email me. I'm happy to share it with you. But it used to be on our webpage a long time ago when we were defending having different deformation values and explaining it. Most manufacturers, from what I've seen, as frustrating as it is for me, won't explain it or debate it at all. They just say, no, you get what you get, and feel free to experiment. And they won't really address it. They won't publish the numbers. It's like a big secret. We try not to be secretive. We'll tell you. If it's not good, we're going to be honest with you and tell you it's not great deformation, it's not pretty, or what to expect. So.
Blake asked if we're going to have any examples of deformity, like maybe like a table that shows, grades of deformity, that kind of stuff.
Yes, we will. Is that Blake Swing?
Yes, sir.
Hi, Blake. Yes, we will have a table that will show expected deformation values. If you go to the bend quality calculator on our webpage in the tech section, I know I just keep saying go to the tech section, but there's a few of those numbers published where it says, hey, if you bend this, you should expect to get this. If you bend this, you should expect to get that in terms of deformation percentage. We just have a few select ones there, generally the ones that are common applications or common bad applications, like 2-inch 120, 6-inch radius. Just not great ratios. 3 to 1 in terms of the D of the die. 2-inch times 3 is 6-inch radius, very minimum. 120 wall on 2 inches, I think an 18 to 1 wall ratio or something like that. 120 is not thin, but on 2-inch, it is kind of thin. So that application has a good amount of deformation as well, 9-10%. So we point out those ones. I did start shooting a video one time that had a narration, and I showed these deformation values. It was shot right here where I'm standing, and the microphone was not plugged in. So I shot some of that video, and it was useless. But we will shoot another video at some point and explain deformation. And the cool thing is now we've got the mandrel attachment, so we can kind of show some of the losses in terms of geometry from bending, what going up a wall thickness would do for you, and what switching to the mandrel would do for you, because these are all valuable things to see. So it's definitely useful.
Mr. Boone, who we sent our donations to down in California, asks if we're going to improve on our dyes and make them better.
I have a prototype upstairs right now to improve on our dyes and make them better. We did experiment with one of our customers, not on them, but with them. And we sent them some experimental thin wall dyes, we called them. They were a non-mantle compatible thin wall dye, and they changed the performance of the bending, but they didn't make it a lot better. They were kind of similar to our old thin wall attachment where they had a bunch of drawbacks in terms of complexity, installation, understanding, or setup. In this case, it wasn't setup, it was all the others. And just not enough benefit and performance to warrant having them go into production. So we didn't do that. But we are continuing to do R&D efforts on die design and other aspects of the machine that could further improve thin wall performance or improve capacity in terms of thick wall stuff. And we will be absolutely releasing those to the public as soon as we can if they work. So the one that I have upstairs has not been tested yet. So we're doing other testing, which I just picked up and showed you, that thin-walled stainless piece. So once that material comes out of the machine, we will be loading up some other stuff that we're playing with, and we'll probably post the results of the tube, but we won't show you the tooling or sell it until it's ready for market.
Blake's being asked, would you consider doing SolidWorks videos to show your methods for computer testing, bends, creating bends outside Bentec?
We might do, Blake asked about SolidWorks demos. We might do SolidWorks demos. SolidWorks is out of reach for a lot of our customers. If they're just doing general fab and they're, buying a welder, renting a shop, getting a lift, doing wrenches and bending tube and installing it and stuff, none of those processes really require SolidWorks. Even those guys that have like a plasma table, they're still not usually buying SolidWorks. They're still usually drawing in something that's cheaper than SolidWorks. So we'd have a limited audience. But obviously Blake is interested, so a few people would. We would definitely be interested in doing that. I'm passionate about SolidWorks and its power, its computing power. CATIA, NX Ideas, there's a whole bunch of them out there that are really good. I mean, Rhino, there's cheaper ones also as well. But there's a bunch of solid modeling programs. Most of them do similar things, different ways. And I'd be happy to do some demos of how I model tubing and how we simulate loading and stuff like that. There is some liability issues with that, Blake, so when we do that, I will definitely caution you and say like, hey, this is the way I've simulated this. This is a good thing to do because I can compare it the same way multiple times and get comparable results, but know that these results might not represent reality accurately to predict the safety of a roll cage or other life-saving structure. So we usually include those kind of, liability limits so that we tell people, hey, this isn't what would happen if you rolled. This is just a good way to compare this because we can compare it to something else and have worthwhile, meaningful comparison between the two. So.
That's a good question. Slow down a little bit. We've been at for almost an hour.
Yeah. So this has been a really great Q&A session. I forgot about giving stuff away. So we've got to do it relatively quick. Who was the third person that asked a question? Let's give them the third prize.
We roll to the top here. This is the question.
Whoever Josh picks as the third question is the winner. If we determine later that was the fourth, they're still the winner. These prizes aren't worth $1 million. It's not worth suing anybody over. Cool? Good. So this is for a shirt and a sticker pack. Sticker pack is 7 stickers. We sell them for $8. These would normally get you entered into our drawing. Next drawing is going to close about 32 days from now. And that's going to be, we're going to draw winners for the XHD benders, both of them here behind me. They're upgraded, powder coated, got hydraulics included. They're pretty sweet. So these are totally separate. These are just drawings for prizes for people who are watching this video right now. So if you're watching, I think the Q&A is done at this point. But we're going to give this stuff away all in the next couple minutes here. We'll pick people. He's trying to find the third person to ask a question. They're going to win the third prize one. In the meantime, I'm going to let you guys figure out who's going to win the second prize one. Whose birthday is closest to today? Going forward into the future. So if you were born today, you win the second place one. Everyone's born today, tomorrow. So anybody born the next, or birthday the next couple weeks, post and tell Josh. This is the honor system. Don't lie about your birthday. It's not worth enough money to warrant lying about. So the second place prize is the hoodie and a sticker pack. So one of these nice independent brand hoodies. They're really soft. They wear really nice and they're a little bit longer, which is helpful if you're tall. I am not, but that's okay. Many of you are.
Landon Hook.
Landon?
Landon Hook.
Landon Hook! You won third.
Yes.
Cool. Landon, you won third prize. Landon Hook. Comments will be rolling in on the birthdays, which is going to be second prize, which is good.
October 21st, November 24th, October 15th is the closest. So
There you go. First prize.
This guy, Dylan Ray's born on the 21st, which was like last week.
Dylan, close. We should have had this video earlier. You'd have won.
October 8th, October 5th, October 2nd.
First person to name the city that we are in right now, Rogue Fabrication is in, wins the grand prize. First person to name the city. Doesn't have to be the state, just the city. Time to figure it out. It's easy. Google will tell you. All right.
So far, Doug Powell's the closest with October 2nd.
Doug Powell's the closest with October 2nd, so a little less than a week away. If you were born closer to today than Doug Powell going forward, you can steal a second prize from him. And if you know what town we live in here, Rogue Fab, what town we're in.
Nick Hoyt snuck in right before a bunch of people.
Oh, Nick Hoyt! You are going to be the most hated guy in this video. You answered, I'm guessing correctly, Sandy, Oregon. Just has to be Sandy though. He beat a bunch of people. There's a notable delay, which is why it took forever. I'm sure he posted the answer like a full minute and a half ago, but there's a big delay from what I say until when you guys actually hear it, which is why sometimes I ask people to answer questions they can't answer them quick. It's not because they're slow, it's because there's a delay. So congratulations, you won the grand prize, which is a shirt, I believe. Yes, it's a shirt and the dimple dies. So those are our nickel-plated dimple dies. These bad boys right here. This has been a fantastically fun Q&A session. Awesome questions from everybody. And please, we're going to put, it's going to be down in this corner if you're watching this not live. There's going to be a logo, Rogue Fab logo. Click that thing and subscribe. We don't monetize our videos. We literally just want to gain an audience so that we can educate and have fun and eventually try to sell you tools. And we would really love the ability to have more subscribers so we can just broaden our audience slightly. So please subscribe if you haven't already, and thank you so much for all the questions. Thumbs up, comment, use the comment box below. Have a wonderful day. Stay safe in the shop.